Imagine this, a robot that doesn't just walk like us, it transforms its body on the fly, stretching taller than a grown adult one moment, then shrinking down to squeeze through a tiny gap the next. It glides across water like some futuristic insect, dives in to swim through currents, and even takes to the air with a little help from fans. This isn't science fiction. It's the latest breakthrough from China, and it's called GrowHR. Developed by a team of innovative researchers at the Southern University of Science and Technology in Shenzhen, this soft humanoid robot is redefining what machines can do in the real world. We're talking about a shapeshifter that's lightweight, adaptable, and ready to tackle environments where traditional robots would fail miserably. Let's dive into what makes GrowHR so revolutionary. At its core, GrowHR draws inspiration from something profoundly human: our bones. Think about it. Human bones aren't static rods of calcium. They're dynamic structures that grow, absorb shocks, and keep us light yet strong. They have growth plates that expand over time, dense outer layers for stiffness, spongy interiors for cushioning, and intricate cavities that reduce weight without sacrificing durability. The engineers behind GrowHR wanted to capture that essence in robotics. Instead of the rigid metal skeletons you see in most humanoids, which are predictable but inflexible, they created growable linkages. These are essentially artificial bones made from soft, expandable chambers, sealed airtight and wrapped in a tough, non-stretchable textile skin. Tensioned cables run through them, connected to rigid adapters at each end to maintain stability. A synchronous cable system ensures everything extends evenly, preventing random ballooning. It's like giving the robot an internal scaffolding that can inflate or deflate on command, allowing purposeful deformation while holding a coherent shape. The results are staggering. GrowHR can extend its linkages, letting the entire robot nearly triple its height, from a compact 0.49 meters to a towering 1.36 meters. That's a 278% increase in stature, making it perfect for reaching high shelves or peering over obstacles. But it goes the other way too. By deflating, it can reduce its height by 36% and its width by 61%, slipping through narrow passages or low ceilings that would trap bulkier bots. Picture a rescue scenario in a collapsed building. Debris everywhere, tight squeezes under beams. Rigid robots might get stuck or require heavy machinery to clear paths, but GrowHR just adjusts its form and crawls through. And speaking of weight, the whole thing tips the scales at just 4.5 kilograms, about as heavy as a large house cat. Each linkage weighs around 350 grams. Thanks to those large internal chambers that keep density low, only 5.8% of water's density. This featherlight build isn't just for show, it's the secret sauce behind its multimodal locomotion. Let's talk about movement, because that's where GrowHR really shines. On land, it can walk at varying heights, maintaining balance through a clever mix of air pressure adjustments, small servo motors, and carbon fiber telescopic guides for added stiffness when needed. The gait is deliberate, with active control algorithms handling stability, especially important when the soft limbs bend slightly under load. At shorter statures, it stiffens up for quicker steps. Fully extended, it's more cautious to avoid tipping. But if walking won't cut it, GrowHR switches to crawling mode seamlessly. By deflating its legs, it lowers the torque needed at the hips, then coordinates the growable linkages with motors to propel itself forward. Alone, the motors manage a sluggish 0.1 millimeters per minute. The linkages by themselves aren't much better, but together, they amplify each other, achieving speeds of 112.2 millimeters per minute, a whopping 1,122 times faster than either method solo. It's a testament to how structural changes can supercharge traditional actuation, turning a gimmick into a game changer. Now, here's where it gets almost magical: water-based feats. Because of its low density and buoyant design, GrowHR floats effortlessly, even with an extra waterproof PVC cover to shield electronics. In tests, it stayed afloat while pulling 25 kilograms underwater, with calculations showing it could handle payloads up to 72.8 kilograms, over 16 times its own weight. That makes it ideal for aquatic transport or rescues. For swimming, it mimics a breaststroke with frog-like kicks from its servo motors. Larger extension angles and quicker recoveries boost speed, hitting peaks of 0.27 meters per second. The inflatable upper body acts like a posture adjuster, lifting the front to submerge more leg volume for better propulsion, speeding things up by 3.4 times compared to without it. In one demo, it approached a simulated drowning person and provided buoyancy to rescue them. But the showstopper? Walking on water. With one-way fins on its feet and 5-kilogram weights per foot for balance, it strides across the surface at 16 millimeters per second. No human or conventional robot can pull that off without sinking. And it doesn't stop at ground and water. GrowHR takes to the skies too. Its lightness means you can attach ducted fans or hitch it to a quadrotor drone for short flights. In experiments, it soared several meters, even covering up to 5.5 kilometers when drone assisted. Imagine dropping supplies in remote disaster zones. The robot flies in, lands, inflates to full size, and navigates on foot or by water to deliver aid. Strength-wise, it's no slouch either. The compliant structures store elastic energy like a spring, releasing it for powerful actions like kicking a ball with force beyond what rigid motors alone could muster. Impact absorption is built in. It withstood accelerations up to 599 meters per second, squared without damage. Plus, that softness ensures safety, bump into a person, and it's like hugging a pillow, not colliding with steel. A 6-year-old could lift it, highlighting its user-friendly design. This isn't just a lab toy. GrowHR's versatility screams practical applications. In search and rescue, it navigates rubble, swims through flooded areas, or flies over hazards to reach victims. For remote deliveries, its compact, deflated form ships easily, then self-deploys. Home assistance? Picture a gentle companion that adjusts size to help kids or elderly without risk of injury. Even in industrial settings, it could inspect tight spaces or handle delicate tasks. The research, published in a prestigious journal, positions this as a foundational shift toward growable, bio-inspired robotics. Lead researcher Hao Liu and his team emphasize how it pioneers multifunctional designs for unstructured environments, enhancing daily life. Zooming out, GrowHR spotlights China's surging dominance in humanoid robotics. Shenzhen, a tech hub, is churning out innovations like this amid a boom in factories dedicated to robot components. Companies are shipping thousands of units annually, with global shipments hitting 18,000 in 2025 and sales soaring 58% year over year. China controls over 80% of installations, leveraging complete supply chains and cost edges to drive prices down. Elon Musk himself has called China Tesla's biggest competitor in this space. But GrowHR stands out by blending softness with smarts. AI-driven controls handle the complex balance of inflation, motor actuation, and environmental sensing. It's not about raw power, it's about adaptability, echoing nature's efficiency. Of course, challenges remain. Speeds are modest compared to rigid counterparts, and it relies on external air supplies for prolonged growth. But these are stepping stones. As AI evolves, integrating advanced perception, like real-time obstacle avoidance or learning from experiences, could make GrowHR even more autonomous. Imagine swarms of these in disaster response, coordinating like a team, or personalized versions in homes that grow with your needs. Looking ahead, this tech could ripple into other fields. Biomimetic designs might inspire prosthetics that adapt to users, or exosuits for enhanced mobility. In space exploration, lightweight, deformable robots could handle microgravity repairs without bulky frames. China's push here aligns with broader ambitions, like sending humanoids to orbit for risky tasks. Engine AI's PM-01, another Shenzhen creation, is already eyeing astronaut roles with millisecond responses and radiation resistance. GrowHR isn't just a robot, it's a glimpse into a future where machines morph to meet the moment, blending human ingenuity with mechanical marvel. It challenges the stiff, heavy norms, proving softness can be a strength. As robotics accelerates, China's innovations like this are setting the pace, potentially reshaping industries from healthcare to manufacturing. So, what do you think? Will China continue to lead the humanoid robot race 5 years from now, or will another player catch up? Drop your predictions in the comments. I'd love to hear your thoughts and spark a discussion. If this blew your mind like it did mine, smash that like button, subscribe for more deep dives into cutting-edge tech, and hit the bell so you never miss an update. Share this with a friend who's into AI or robotics. Let's spread the word. Thanks for watching, and I'll catch you in the next one.